Hello, curious minds. Welcome back to Solar System's Wonders. Today we're venturing 4.5 billion kilometers away to the edge of our cosmic neighborhood, to a world of howling winds, deep blue oceans of gas, and a stormy giant whose secrets are only beginning to unravel. It's a place where winds whip faster than the speed of sound, and ice volcanoes may hide the key to life itself. Get ready to explore the mysterious and magnificent Neptune. Neptune is so far away, it's invisible to the naked eye. Even with the most powerful telescopes, it appears as a tiny blue dot in the vastness of space. We needed mathematics to find it. The precise calculations and predictions led us to this distant world. In the 1840s, astronomers noticed Uranus wasn't moving as expected. Its orbit was being disturbed by an unseen force. Something unseen was tugging on it. This mysterious force was none other than Neptune, exerting its gravitational influence from over 4 billion kilometers away. Two brilliant mathematicians, Urbain Le Verrier in France and John Couch Adams in England, independently calculated where this hidden planet must be. In 1846, Johann Galle at the Berlin Observatory pointed his telescope to the predicted location. And there it was, exactly where the math said it would be. Neptune had been found, not by sight but by the power of human curiosity and ingenuity. This discovery sparked our curiosity. What other secrets could be hidden in the depths of space? What secrets does this distant world hold? Could there be more planets beyond Neptune waiting to be discovered? What can it teach us about the universe and our place within it? Neptune challenges our understanding of planetary formation and the dynamics of our solar system. Let's embark on a journey to explore Neptune, the enigmatic blue giant. Neptune is a giant much larger than our Earth. If Earth were a nickel, Neptune would be a baseball. It's a ball of gas and ice with a solid core deep inside. The core is probably about the size of Earth itself, but much denser. Unlike Earth, you can't stand on Neptune's surface. It has no solid ground. Instead, its atmosphere blends into a slushy, icy layer beneath. The pressure there is immense, crushing anything in its path. Neptune's blue color comes from methane in its atmosphere. Methane absorbs red light from the sun, reflecting blue back into space. This gives Neptune its striking appearance. But there's more to Neptune than just its size and color. It's a dynamic world with raging storms and supersonic winds. Let's take a closer look at the turbulent atmosphere of this blue giant. Neptune's atmosphere is a wild place. It's made mostly of hydrogen and helium like Jupiter and Saturn, but unlike its calmer siblings, Neptune's atmosphere is constantly churning. Winds on Neptune are the fastest in the solar system. They can reach speeds of over 2,000 kilometers per hour or 1,200 miles per hour. That's faster than the speed of sound on Earth. These powerful winds whip up massive storms. One such storm, the Great Dark Spot, was observed by Voyager 2 in 1989. It was so large it could have swallowed Earth whole. But Neptune's wonders don't stop there. Let's move beyond the atmosphere and explore the rings that encircle this blue giant. When we think of rings, Saturn usually comes to mind. But Neptune has rings too, although they're much fainter and harder to see. They're made up of dust and small icy particles. Neptune's rings aren't uniform. They have clumps of material, making them appear clumpy or lumpy. Scientists believe these clumps might be caused by the gravity of small moons orbiting within the rings. These rings are more than just beautiful ornaments. They hold clues to Neptune's past. By studying their composition and structure, scientists can learn about the processes that shaped Neptune and its neighbors billions of years ago. Neptune's magnetic field is one of the most intriguing and mysterious aspects of this distant planet. Unlike Earth's nearly symmetrical magnetic field, Neptune's field is tilted and offset from its rotational axis. This unusual orientation presents a significant puzzle for scientists. The magnetic field of Neptune is thought to be generated by a dynamo effect, similar to other planets, where the motion of electrically conductive materials in the planet's interior creates a magnetic field. However, the exact structure and dynamics of Neptune's magnetic field remain unclear. What makes Neptune's magnetic field particularly fascinating is its tilt, about 47 degrees relative to the planet's rotation axis. This is quite different from the relatively aligned fields of Earth or Jupiter. The field's offset and tilt suggest that Neptune's internal processes may differ significantly from those of other planets. Future missions to Neptune could offer new data to solve this magnetic mystery and refine our knowledge of planetary magnetic fields in general. Neptune is a mysterious and captivating world, surrounded by a family of moons that add to its allure. Neptune has 16 known moons, each more intriguing than the last. These moons vary greatly in size, composition, and characteristics, making them a fascinating subject of study for astronomers and scientists alike. They're named after various sea gods and nymphs from Greek mythology. The largest and most fascinating moon is Triton. Triton stands out not only because of its size but also due to its unique features and the mysteries it holds. Unlike most moons, Triton orbits Neptune in the opposite direction of the planet's rotation. This retrograde orbit is a rare phenomenon, leading scientists to speculate that Triton may have been a dwarf planet or a Kuiper belt object, captured by Neptune's gravity, rather than forming alongside it. Triton is a world of ice volcanoes and nitrogen geysers. These geological features indicate that Triton is geologically active, with internal processes that continue to shape its surface. Its surface is covered in frozen nitrogen, giving it a pinkish hue. This frozen nitrogen creates a landscape that is both beautiful and alien, with a surface temperature of around -235 degrees Celsius. Triton's unusual activity and composition make it a prime target for future exploration. The other moons are smaller and less understood. Despite their size, these moons hold valuable information about Neptune's history and the dynamics of its moon system. Each moon has its own story to tell, contributing to the larger narrative of Neptune's past. Let's journey back in time and relive humanity's first encounter with Neptune. Our closest look at Neptune came in 1989, when NASA's Voyager 2 spacecraft flew past the blue giant. It was a historic encounter, marking the first time a spacecraft had visited this distant world. Voyager 2 beamed back stunning images of Neptune and its moons. We saw the great dark spot, the faint rings, and the icy surface of Triton for the first time. The data collected by Voyager 2 revolutionized our understanding of Neptune. It revealed a world more dynamic and complex than we ever imagined. But Voyager 2's flyby was brief. It gave us a tantalizing glimpse of Neptune, but left us with more questions than answers. To unlock Neptune's secrets, we need to return. Scientists are eager to return to Neptune. The allure of this distant icy giant continues to captivate the scientific community. With each passing year, our technology advances, bringing us closer to the possibility of unlocking Neptune's many secrets. Future missions are being meticulously planned to study this enigmatic planet in greater detail. These missions involve years of preparation, intricate design, and cutting-edge technology. These missions could involve orbiters, which would circle Neptune for years, gathering invaluable data about its atmosphere, magnetic field, and more. Triton, Neptune's largest moon, is particularly intriguing for future exploration. Its geologically active surface with ice volcanoes and nitrogen geysers, and the possibility of a subsurface ocean make it a prime candidate for detailed study. A lander could analyze the composition of Triton's ice and search for signs of past or present life. Neptune's rings are faint and composed of dust particles, and studying them could reveal much about the planet's history and the dynamics of its ring system. Moreover, future missions could provide clues about Neptune's interior, which remains largely a mystery. By studying the planet's gravitational and magnetic fields, scientists hope to infer the structure and composition of its core and mantle. Despite what we've learned, Neptune still holds many secrets. One mystery is the origin of its internal heat. Neptune emits more heat than it receives from the sun, suggesting it has an internal heat source. Another puzzle is the nature of its magnetic field. Neptune's magnetic field is tilted and offset from its center, unlike Earth's more symmetrical field. This irregularity raises questions about the planet's internal structure and the dynamics of its magnetic field. And then there's Triton, with its retrograde orbit and icy volcanoes. How did it form? Where did it come from? These are just a few of the many questions that continue to fascinate scientists. But Neptune isn't just a collection of mysteries. It plays a crucial role in the delicate balance of our solar system. Neptune might be the farthest planet, but it still exerts its influence on the solar system. Its gravity affects the orbits of objects in the Kuiper belt, a region of icy bodies beyond Neptune. Some scientists believe Neptune's gravity might even help protect the inner solar system from comets and other potentially hazardous objects. Neptune's role highlights the interconnectedness of our solar system. Even the most distant objects can have a profound impact on their surroundings. And there you have it, the wonders of Neptune, a world where the winds roar, the ice hides mysteries, and the deep blue remains unexplored. But our journey through the outer solar system is far from over. Next, we venture even further into the darkness, to a tiny, icy world that once held the title of the 9th planet. That's right, we're heading to Pluto, a place of frozen mountains, mysterious plains, and perhaps even a hidden ocean beneath its icy crust. What secrets could this distant dwarf planet hold? Before we get there, I'd love to hear from you. If you could explore one of Neptune's moons, which would you choose and why? Let me know in the comments below. And don't forget to like, subscribe, and hit that notification bell so you don't miss our next adventure. Thanks for watching. Until next time, keep looking up.